Welcome to another Fenestration Canada podcast.
This is Tech Talks, live conversations about the regulatory environment with Jaugelis.
Okay, we're now live on YouTube and on Zoom for this episode of Tech Talk. So today the episode is presented by Federated Insurance, and I'll let you introduce us to our panelists today.
Yes, thank you. So our topic today on Tech Talks is the growing concern about embodied carbon and what that can mean for the future of wood windows in Canada. The one thing I've noticed in talking with folks in our industry over the years is that a number of Canadian companies that used to manufacture wood windows and, let's say, vinyl windows, they've discontinued their wood window lines because it was challenging to meet the energy requirements. Other companies that just made wood windows have just decided, especially smaller fabricators, have actually discontinued fabricating them for those kinds of reasons. And so we're seeing a market right now that's dominated by, synthetic materials such as PVC and fiberglass or aluminum. And it seemed like wood windows have kind of been marginalized in some ways in the marketplace. And one thing that I've noticed in following the discourse in construction these days is that there's been a growing concern among architects, among anyone who's concerned about climate change, and even institutions such as universities that have large portfolios of buildings that are consciously making decisions that in the future, all of their construction is going to be carbon neutral or net zero carbon as a goal. And it's coming to dominate I wouldn't say dominate, it's emerging as a real important issue. And so we're looking to explore that a little bit today and see how the embodied carbon discourse can actually perhaps get us to think about wood as a building material and wood as a window building material in a new light. Our guests today are Austin Parsons. Austin is actually a Fenestration Canada member with the Parsons Lumber, but he's also an assistant professor at the Dalhousie School of Architecture. And he's going to introduce us to the discourse why embodied carbon is emerging as an issue. We also have member company Westech Windows. Carl Cartwright is representing them. And they've introduced a wood passive house window. So we're going to talk to them about why they did that and what's special about that product. And our third guest is Greg Godbout of Randgate, who has been instrumental in helping companies like Westech actually be able to, design and introduce products like this. And Greg has a very wide experience in wood fabrication, and I think he's got a lot to contribute to our discussion today. So I'm going to look forward to hearing from him. Now that I've introduced you, I'm going to ask you to introduce yourselves in your own words. I wanted just to let people know why we've invited you to be panelists, guests on our show today to discuss this topic. Austin.
Good afternoon. Thank you very much, Al. Hi, folks. As Al said, I'm a assistant professor at the School of Architecture at Dal. I teach in the Building Technology group. Some of the course subject areas I teach are building science, life cycle analysis, heritage conservation, and most recently, since COVID, computational design. And that's a half-time tenured position. And the other half of my life, I have a company, as Al mentioned, called Parsons Lumber Company. We make wood windows and doors primarily for the heritage market in Nova Scotia and other parts of the Maritimes. We've been doing that for about 20 years, and I've been teaching a little bit longer than that. But, there we are. And I think that's the quick introduction. And my point of my conversation, or my initial slide deck show to you folks, will be talking about why embodied carbon is important and why people are beginning to add a lot more importance to it in the design solution, design problem space. Thank you.
Kyle, tell us about your role at Westech.
Hello, everyone. I'm out on the West Coast, so it's going to be a good morning for me, and maybe not a good afternoon, but I'm the technical manager here at Westech, and I primarily work with inside the technical department, research and development of new product lines, both on a grand scale and small. I do a lot of in-house thermal modeling from a initial design aspect, and after the fact to develop glazing packages and such. Also work on some of the in-house engineering after product has landed and we're manufacturing. So I do a lot of work on new product lines and trying to upgrade or increase productivity from existing product lines. So my point of discussion here would be why Westech introduced a passive house wood window into the marketplace, and our challenges of getting it to the marketplace, both in thermal modeling and of course, NAFS testing.
Greg.
Well, good morning, good afternoon, everyone. Like Kyle and like Al, I'm sitting out on the West Coast in Vancouver, Canada. I head up a group of companies called the Rangate Group. We comprise of specialized engineered cutting tools, supply components like gasketing, those related elements, both the design and engineering support for the wood window industry. Our main focus of the marketplace is in solid wood joinery, which lends us towards windows and doors. We also have a related company for the CNC-driven window machinery. And we're very heavily involved in the offsite construction industry now in the last 3 or 4 years, which is also lending itself quite well to the window and door industry. So a collective group of companies really there to support the industry. We've been doing this for well over 15 years now. And myself personally, I've been in the industry for almost 40 years now. So I'm quite involved and have very good connections worldwide for what's happening in the marketplace, not only in North America, but also outside of North America, and how that impacts all of our clients and also their clients. So really from our side, we're here to support the industry, to support not only the panelists that are on board right now, but also the multitude of questions that hopefully are derived from this. So looking forward to a good discussion.
Thank you very much, Greg. So Austin, over to you. Fill us in now on the embodied carbon issue.
Okay, I just wanted to mention one thing. I forgot to say that Dalhousie, for those who don't know, is in Halifax, Nova Scotia. So this is actually a coast-to-coast webinar. So there we are.
There you go. Yes, we are.
Okay, hold on 1 second. Let me see if I can get through this one. Okay, you should be seeing my slideshow right now. I'm hoping people see that. I can't see anyone else.
We've got the screen that shows all the slides.
All the slides, not the main slideshow.
Yeah.
Oh, okay. That's not good. Try that again. Now that should be okay. That good?
Perfect.
Okay.
Yes.
All right. When Al and I were talking about this presentation, essentially, it's not going to be a very technical one. What the focus is going to be is just telling people what upfront embodied carbon is and why it's important to designers, architects, manufacturers, hopefully builders, and society in general. As part of that conversation I had with Al about this, he sent over this copy of Builders for Climate Action. I'm going to show you 2 slides from that textbook, but I wanted to give reference to where they came from. And if you have an opportunity to look at this book, it's a good one, and it does introduce the subject very well. First thing I wanted to say is, why is embodied carbon important? You know, come to it. There's a couple things. There's embodied carbon when you deal with a building, and there's operational emissions or operational carbon. Historically, that has not been considered. But if you can see from this slide, you know, what we're dealing with is a time crunch. As you all know, climate change is an issue. What's driving climate change is the burning of fossil fuels, which in turn produce or off-gas carbon dioxide that gets into the atmosphere. That's one of several greenhouse gases. that has the ability to absorb long wave radiation from the Earth, not allowing that radiation to escape in space. And as a consequence of that, we're warming up the global environment. And most folks have heard the 2050 and the 1.5 degrees Celsius temperature tip. But where we are here in 2020, what the Interprovincial Panel on Climate Change has told everyone is that we've got to act earlier than later. And here we are at 2020, and in 2030, the next 10 years, they're hoping for some reduction in emissions of CO2 and fossil fuel in general. They don't think what they're really trying to stress here is if we delay and procrastinate, we're going to get in trouble. So it's better to act earlier than later. And one thing about operating emissions, and you can see this sloping line, or like a right triangle, essentially that's the cumulative addition of carbon as the building operates over time. So the first rectangle is 1 year, the second one is 1 + 2 years, 1 + 2 + 3, et cetera, down to 2050. This yellow line, though, is the embodied carbon line. That's the carbon that's emitted into the atmosphere now because of the building of the building, and all that associated with it. And what people are looking at is trying to stop these emissions or reduce these emissions now because they are being emitted into the atmosphere today. That's the big key difference here. Embodied carbon is emitted immediately, operating energy is emitted over the time, and we have to act now. So that's the first thing I wanted to go to. Time is a critical factor. Second one here is this is nothing about the numbers. We can talk about those at some point, but basically the way people are thinking about it is now they're trying to drop total net carbon emissions, and they also want to get into a position where buildings are net carbon storage units. And what's interesting about this is you've got various materials that are used to create various assemblies, and through a mix and match of existing known materials, we can move from high carbon emission buildings to relatively high carbon storage buildings. And as you can see from the Fenestration Canada line, they move from vinyl windows to aluminum clad windows to wood windows, all technologies we have today. So it's not as if we have no solutions to these problems. So what I wanted to talk about now is that why architects and designers are beginning to think this is a really important question, i.e. in particular embodied carbon or upfront embodied carbon. I wanted to say that architects, designers historically have had an interest in materials. This interest has been with the aesthetic or plus how the material would perform internally. And what I mean by that is relative to the building's needs, structural, acoustic, comfort, visual durability, some things we're all familiar with. Today, with this accentuated interest in environment and carbon, this interest in materials has expanded to include how the material will also perform what I call externally, relative to how the material's creation would impact the natural environment. And these impacts are defined according to non-renewable energy sources, resource depletion, eutrophication, acidification, human health, and carbon. And when going from the internal to the external, when going from just thinking about the building itself to thinking about it in the context of the natural environment, architects and designers would like answers to two related asks when they're talking to residential window manufacturers. The first ask starts with this idea of carbon footprints. What's a carbon footprint? It's something expressed in kilograms per CO2 equivalent. It's a mass number of one or more greenhouse gases. Greenhouse gases are those gases that have the ability to absorb long wave radiation from the atmosphere, not allowing it to leave space, emitted in the atmosphere over a given area over a certain period of time. And that's important. The time horizon people look at when they deal with carbon footprints is about 100 years. The carbon footprint of a home or a residence is made up of three parts: carbon to make it, carbon to operate it, carbon to maintain it. And the carbon footprint of a residential window is whatever specific contribution that window has to the carbon footprint of a residence, just so you're relating to the equation above, or the residence. We're going to focus on carbon to make it. So that's one of the three carbon emissions that make up the carbon footprint of a building. When you're talking about upfront embodied carbon, first thing I wanted to mention is the definition of embodied, and it means to include or contain something as a constituent part. In this case, upfront embodied carbon is the carbon emissions included, contained, accounted for in the making process. And the making process can include manufacturing, assembly, or any activity associated with the construction of a component system, up to including the building. So this is the carbon that's emitted into the atmosphere before the building actually is commissioned and up in operation. But it's fundamental to making the building. Or a window. Now, when you're dealing with a window, the upfront embodied carbon is a combination of the carbon and the materials themselves, the energy or the carbon expended to collect those materials, the carbon associated with the assembly of those materials, and the carbon associated with the transportation of those materials if you're taking that window to site. Just something to keep in mind that with different window constructions, similar window constructions made by different manufacturers, or similar window constructions made by the same manufacturer but at different locations will have or could have different upfront embodied carbon emission values. These are things that architects and designers know about, they think about, and when they're talking to you as a residential window manufacturer, you need to get a handle on, that's a colloquial obviously, these upfront carbon numbers from your system, your processes, your windows, and in turn you have to pass them on to the owners, builders, architects, and designers of these residential buildings. And this is needed if you want them or if they're going to spec or use your windows in a build. So this is, in other words, the type of information you need to start thinking of collecting and passing on to those that want to buy your windows or use your windows. So they'll be able to do that in knowing full well the upfront embodied carbon numbers. The other thing I wanted to mention is in addition to all of this, or another layer of all this, there are changes coming in how architects, consultants, builders, designers are designing buildings. There's emerging understanding that design decisions about materials, products, and systems need to be made at the schematic design phase. Historically, a lot of design decisions about particular windows, particular doors, et cetera, were made in the contract document phase. A lot back further from in the design process, way before or after all the significant decisions about how the building is going to perform have been made. Now that's changed, or in the process of changing. Today, there's a much more holistic approach to how buildings should be designed and built. And what I call it is less silo, more collaboration. What I mean by that is historically, we all know this, you would have a designer in their silo, you'd have an engineer in their silo, you'd have a builder in his or her silo, you'd have a consultant in their silo. They would never really talk together. They would get, one would develop plans, and those plans would be sent to engineers or HVAC people to put the mechanical in the building. That would then be sent to a builder for pricing. And then the builder would then go to the manufacturers for product, and then they would hire the trades and go from there. That's changing. Now you're getting teams of people together in a space very early on in the design process, making significant decisions about how the building will perform. And people also recognize that begins with identifying owner wants and what society requires, what I call the comfort carbon conundrum. When you're dealing with an owner, you're primarily dealing with individual people. When you're dealing with society, you're dealing with the group. And sometimes the owner's interests and the society's interests don't gel. So you have issues, but you got to get those resolved very early on in the process. Sometimes they do gel and it moves a lot better. But people are beginning to think differently, and that's what I'm trying to impress upon everyone here about how to get buildings built. And they recognize that it's a team approach, and everyone has to come in, provide their expertise early on, and from that come up with some holistic interlocking decisions that will make it a better build. At the residential level, it means early conversations with the building, HVAC contractor, and suppliers. And this applies to thinking of both tract builders and custom builders. So it's not a function of how many buildings you're building or how big the project is. Every building makes a difference, particularly when it comes to operating energy and embodied carbon, or operating carbon and embodied carbon. Thought you might find this interesting. What we're doing now at the School of Architecture at Dal is we're beginning to take this type of thinking and applying it to how we teach our classes. In the design class, I'm associated with what they call a building systems integration course, which is a comprehensive design class. And we're beginning to, at the course creation level within the teaching groups very early on. So for next winter, I'll be having these conversations for next winter's class in the next few weeks. We'll be talking about ways to integrate design objectives with technology objectives at the course level. So for example, while dealing with the aesthetic and ambience, design a building with an energy use intensity of X and a total net carbon storage value of Y. I mean, for next year's class, that's the question I'm going to be asking myself, how to create the technology side of this course. Once I get the designers on board, so we would design a building with an energy intensity of X value and a total net carbon storage of Y, getting students involved and interested in both the embodied carbon question and the operating carbon question. Other classes we teach at the school include LCA classes, where we will be introducing environmental product declarations and product category rules for windows next year. So these are things that good students will be asking for now as opposed to later. One other thing I wanted to mention from, I don't know if anyone listened to last Tech Talk, but there was this idea of how performance-based approach is actually a better moneymaker than prescriptive approach. We've been doing that in the school for several years, talking more about performance-based approach as opposed to prescriptive. So for example, while students would know about the LEED programs or the Green Globe program, we're not really teaching that. What we teach is we give them performance objectives, ask them, say, we would like you to accomplish this. We provide them the tools in terms of computational analysis and the software and the ability to use that software and how to use it in a design problem, and then ask them to create design solutions and then prove it through that software. So that's what we're also doing at the school now. And one thing that's very important here, I'm going to come back to that because it tells you as someone who has product and wants to talk to architects, wants to talk to designers, wants to talk to students who will be the architects in the near future. Like everyone, what sticks when you learn is when an issue or a solution is introduced and explained to you or the student at a point in time when they need this information, help them solve their design problem of the moment. In other words, they learn best when they identify there's an immediate need for them to learn something, and that's when they're most receptive to these ideas. So that's the other reason why we're trying to integrate this into design. Obviously, an architecture school is a design school. Students take design very seriously. That's why they're there. So that's the times that we can start teaching them, or hopefully they learn a lot of these ideas that I've just talked to you now in the immediate context of a specific design problem that then carries forward into their career.
At this point, Austin,
okay.
I wonder if I could ask you a question.
Sure.
If we go back to the previous slide.
This one?
Yes. Maybe we could just review LCA, environmental product declarations, product category rules. Basically, people might be wondering about these terms. And when we talk about, let's say, the carbon, how much embodied carbon there is in a product, how do you answer that question? I guess, are you coming to that still in the presentation?
Yeah.
Okay, then I'll leave it for then. You'll deal with it later. Okay. Thanks.
Okay. Yeah. That's when I talk about how the manufacturers can respond to these questions.
Yes.
Okay.
Perfect. Yeah.
Hold on. Okay. Back to my flow. There we go. All right. So one thing that your architects will be asking questions to manufacturers in the next few years is, do you sell a window with a total net carbon emissions value of X or lower with an energy efficiency number of Y? So what they're doing there is they're no longer asking you to, if you sell a window with an energy efficiency number only, they will be put it in the context of its embodied embodied carbon emissions costs, quote unquote. What they will also be asking, and this is when I was preparing for this presentation, I didn't realize it until I actually started thinking about this part of it. People will also start asking manufacturers about carbon windows that actually store carbon. And this is obviously a segue into wood windows, but it also applies to other window categories. But so do you sell a carbon storage window with a storage number C that comes with an energy efficiency number of D? Now, obviously, this is what architects really want and designers want sooner than later, is a reasonably priced, aesthetically pleasing, durable, low maintenance, energy efficient window with a low upfront embodied carbon emission number or a high carbon storage number. I'm just saying that now people are beginning to think about it in the context of operating plus embodied carbon. That's coming sooner than later. When you're a manufacturer, how do you deal with all this sort of stuff? Well, when I'm looking at it, I just want this, if I was a manufacturer, which I am, and I'm looking at the windows that we make, and some architect knocked on my door and asked me the question I just asked the group, I would say, oh, okay, let me give that some thought. And when I gave that some thought, I realized that, there's either 3 or 4 steps that I have to consider. I'm considering 3 steps if this person just wants to know what the embodied carbon number will be once my window leaves my shop, or if they want to know when it goes to the site. I just have to add another element there. But the first part of it is I need to understand what materials make my window and where the carbon comes from with those windows. So obviously I would have a glass, double or triple pane, the coatings, the gas, the edge spacers, weather strip, hardware frame, and finish. These are all things that I now have. I know where they are, and obviously like everyone else, I know how they make up a window, but now I got to think about the upfront embodied carbon from those products, talk to my suppliers and try and figure out ways to reduce that carbon emission number, so I can then take that savings and bring it into my workspace. Other thing is that when I'm collecting this information, I have to consider trucking. So obviously it makes the most sense for me to deal with local people. If I have to bring product in from long distances, then I'm getting stung with that number. Assembly in my shop, that's something that's interesting. Yes, I've got to make materials, but I also have to look at my building as a embodied carbon producer. And I have to try and figure out ways to keep a productive work environment, but at the same time, reduce my carbon footprint by looking at my lighting strategy, my heating strategy, et cetera, et cetera. When I take all those first 3 components or 3 parts, that's what they call a cradle to gate analysis. You might have heard that term, but that's where the accounting comes in, and these are the items I have to consider. When I want to look at cradle to site, I would just add the trucking to site. So obviously people are going to, they're going to want to buy local. So obviously my greatest market is the HRM Nova Scotia market, because my trucking costs are less. But these are the ways I now have to think about dealing with my product in an embodied carbon world. An environmental, talked to a second ago, an environmental product declaration is a way that the academic side of an LCA feeds into the practical or the manufacturer side of environmental impact. It communicates to the consumer what a product is made of and how it impacts the environment across its entire life cycle. They're typically third-party generated using International Organization for Standardization. Don't ask me how that becomes an acronym for ISO. It should be iOS, but anyway, it's also, we recognize that national compliance. So what it does is environmental product declaration essentially identifies all the various impacts, environmental impacts, and percentages or levels of those environmental impacts a particular product will have based on what it's made out of, based on where the products are obtained, where it's assembled, where it is assembled, and how efficient that plant is at assembling. It's the Windows upfront embodied carbon number. Just I want you to recognize this, that while we're focusing on embodied carbon today, it's not the only thing that these environmental product declarations consider. It's one of a few of them, as I talked about a moment ago. It's part in the embodied carbon number is 1/3 of the carbon footprint number, and the carbon footprint is one of several environmental impacts, all considered in the environment product declaration. To make sure that everyone is following the same environmental product declarations, and these would come from everyone who makes a window as a specific manufacturer would each have their own environmental product declaration. So in that sense, it's a scorecard. And when a designer or an architect is looking at window options, they would be looking at everyone's environmental product declaration to compare the various options they have. To make sure that everyone is playing with the same rule book, you have what they call a product category rules. And these are set for various types of products. You know, windows would be one. There's would be asphalt, I'm thinking, is another one. I believe the vinyl industry is putting one together for vinyl windows. And these would basically say, when you're creating your environmental product declaration, you have to follow and do these specific tasks in a specific order, covering this type of information. And you do that so that a specifier, an architect, a designer, a builder, et cetera, can do an apple-to-apple product comparison. And it ensures functionally similar products are assessed in the same way when conducting the life cycle analysis. And I said there that that sets time and space boundaries. That's always a very interesting, complicated, confusing part of an LCA, is what time and space boundaries you determine or set when you're doing that analysis. And when students ask me that question, the simple answer is you set them with those elements that you have some control over. I can talk about more of that if people want to, but that's the simple answer. And then once you do that, you're able to get a proper set of rules, a proper set of information. So when you put those EPDs out, you're getting that apple-to-apple comparison you want, and with some sense of security or some sense of familiarity. So what the manufacturer needs to do, you need to understand the carbon emissions from the materials you purchase to make your windows. You may or may not be doing that now. You're going to have to go back and talk to your glass people, in my case, my wood suppliers, where I get my edge seals, where I get my weather strip, where I get my hardware. Ask them to do these analyses, ask them to figure out ways to cut their carbon costs. I also have to understand how my shop works, how I assemble my windows, how I can do that much more efficiently from a carbon point of view. Example being, I'm going to be changing out, or I have changed out my lightings to LEDs. We used to heat with a wood furnace, or we still do, using our scrap wood to heat the building. Well, now I'm going to have to be moving to heat pumps. So these are the things that I'm going to be doing. So when I put my EPD together, my embodied carbon numbers are as low as they can be. And also one other thing is, and you need to, I will also be looking at ways to design windows to meet a step. And I don't mean that, I mean that in the sense of an idea, if not a legislation progression from reduced emissions to net zero to storage able over the next several years. You know, that can happen. Al will be better to this than I am, but I'm thinking between now and the next 10 or 15 years, I'll be going from where I am to reduced emissions to net zero emissions to storage able windows. And for each of those, I'll have to include my EPDs that have followed my relevant PCRs so that everyone can do that apple-to-apple comparison. I'm just going to do one more thing. I'm going to end off the presentation with a few more slides here. What I wanted to do is give you some numbers about, you know, what it means for upfront embodied carbon. These are in kilograms CO2 equivalent. Typically, so this is just kilograms of, for this particular case, and this is the Sanat and Kutner. It's a fairly well-known paper in this field. So these are the numbers I got from them. So when they did their analysis, they said that a window, all other things being equal except for the frames, had a wood frame, it produced 130 kilograms of CO2 per equivalent. PVC window 258, aluminum 486. There's nothing more to get out of these numbers. You know, yes, you can say a window is 1, PVC is 2, and aluminum is 4 times the carbon footprint compared to wood. That's not the point. The point is it just gives you an order of magnitude analysis of how much carbon we're actually talking about in a given window. So it's not astronomically large. It's not very small. It's what it is. So that's the reason for those numbers. One thing I haven't talked about at this point, what I've been implying is a lot of the carbon that people are using is based on fossil fuels, as I said a second ago. And that's where most of your carbon footprint is generated. What wood does, though, is it can store carbon. Everyone recognizes that. It can sequester it. It's called biogenic carbon. It's part of the chemical composition of wood, and the carbon from the atmosphere is sequestered into the wood and held into the wood or the tree until at some point down the road that tree is burnt, or the or the window frame in that window rots. So all I can tell you is it's not something that happens in perpetuity. It's something that may happen up to 100, 120 years of locking carbon in the atmosphere. You add to that the 60 or 70 years or 80 years it took the tree to grow. So you're looking at some ballpark figure of about a 200-year sequestration period. At some point, though, that carbon is going to be re-released back into the atmosphere. So it's not a permanent solution. That's why I call it a temporary solution. But people do use that number. What's also important to know is that if you wanted to figure out how much carbon is actually in a piece of wood, and I'll come to this as the last slide, they can use this equation, which basically says that 1 kilogram of wood is equal to 1.6 kilograms of CO2 equivalent. And that's because based on the chemical formula of cellulose and the moisture content of 12%. So basically wood is made up of 50% carbon. And there we are. So if I were to take the numbers I talked about a moment ago, in that textbook, I said you had a frame volume of 0.7 meters cubed. They had a fairly big window there, which had a surface area of 1 meter squared. I said it was about 3 inches thick. Using that number I just gave a second ago, I said if I made a window out of white pine, which we do for the heritage market here, or I've made one out of white oak, which I've done as well, the densities of the wood are different, and that makes a huge difference. So then the frame weight goes up from 31 kilograms, which is heavy, to a white oak frame, which is even heavier. The carbon footprint for those windows is the same as I mentioned a second ago, 130 and 130. The biogenic carbon from the white pine, it represents 50 kilograms per CO2 equivalent, from the white oak 87. So the net carbon footprint would be the difference between the two. And so as you can see with in calculating or including the biogenic or the sequestration of carbon as part of the equation, I can reduce my carbon footprint in my wood window 38% if I'm using white pine, or 66% if I'm using the white oak. Al, that's it. So I just wanted to give people a quick presentation, and there we are. So I'm going to move off of this, or I'll wait for you. Sorry. Go ahead.
Go ahead. Go ahead. I think we can close the slide now and get you back on screen.
We have, Al, just so you know, we have one person that wants to talk with our panelists, and we have one question.
Okay.
Here. So do you want me to, I'll ask the question first. I'll read the question. It's from Patrick. So are there any software tools out there to calculate carbon inputs that you know of?
I think there's a tool. The short answer is there's several tools open source tools to calculate LCAs. There's nothing specific that I can think of to calculate carbon. It's a fairly straightforward equation though. So if you wanted to, I could talk to you about that at some point, but I'm not familiar with any embodied carbon tools out there, open source or provider software. I am familiar with several open source LCA tools. They come from the ETH, the Swiss technical school, and it's called Bombex. That's one. And there are several tools that are connected to the Revit software for the BIM modeling, if that helps.
Okay, and also we have Mike, I think, who raised his hand here, so I'll try to patch him in. I guess he had a question.
I won't be able to see you, Michael. I'm sorry, but that's...
So Mike,
okay.
You should be online.
Can you guys hear me?
Yes.
Yes.
Okay, great. Great topic, great tech talk. Been looking forward to this one. Mike Bruno, president of Everlast and president of ThinkTank. So I have a question. With the push by the government to go to zero emissions, or these carbon footprint studies that I've been calling them, what is the government going to do to help with natural resources that we need in order to produce our windows? For example, in glass, most of our glass, no glass is manufactured here in Canada. It's all coming in either from the US or offshore. Will a window, for example, that's built offshore that has a local glass manufacturing plant, and when I mean glass manufacturing plant, I need the raw material, and they put it into a completed window shipped into Canada, will that have a better scorecard than a window that is bringing in glass and hardware and weather stripping from offshore, because we're not building any of the raw materials that we need to build windows here in Canada? Will that completed window have a better number than a window that is manufactured here in Canada, 20 minutes away from the job site, but has to import all those raw materials from offshore or our southern friends to our southern friends. Maybe you can answer that, maybe you can't, but it's quite concerning for me anyways.
Okay, I had a hard time hearing a lot of that question, but my sense, what I got from the question was a sourcing of materials versus assembly, and I'm assuming that would relate to the carbon. The carbon number would primarily be biased by the transportation costs or the transport of carbon. So I would have to do a calculation, or anyone would have to do a calculation to see what are you transporting? Where are you transporting more? If that's the answer to the question. And I don't know. I mean, I'm sorry, I couldn't hear the question in its entirety, so I'm trying to fill in the pieces as I'm talking to you. But
basically, is the federal government, the Canadian government, going to help and assist in having raw materials manufactured in Canada, for example, glass, because we don't have a glass manufacturer in Canada. And we have to compete. Canadian manufacturers are going to have to compete with completed products that are coming in offshore that have locally sourced hardware and weather stripping and glass, whereas Canadian manufacturers have to import all that raw material from offshore or the US predominantly in order to produce their windows. So what effect will that have on our rating or our carbon number if we manufacture in Canada compared to someone who's manufacturing complete product offshore?
I think it's going to give a higher Canadian number.
So how do we protect Canadian manufacturers then? Is the government going to step in and help with getting these natural resources that are required and process them into thin raw goods that we can use as manufacturers? Because it's great to take care of emissions, which all of us want to do. However, the problem is we're going to eliminate every manufacturer in Canada.
Yeah,
because we're importing all the raw material. I mean, myself personally have to import all my hardware from China. There's no one who makes it. Yeah.
No, I mean, if you want to buy Canadian, all the Canadian manufacturers would have the same issue. So it would then, I would think, depending on locations, come down to how efficient each manufacturer can make a window within their own internal processes, because the transportation costs are the same. But having said that, there's no question that you're at a disadvantage because of the issues that you just mentioned.
So how is that? Well, we know that builders, whether they're tract builders or custom home builders, they're going to go for probably the best priced option. But when they're similar in price and have a better carbon body footprint, well, that just eliminates the Canadian manufacturer. So how do we, as an association and an industry, protect our manufacturers in Canada? Because going down this route is going to decimate our industry.
If we don't do anything about it, you're absolutely right. I think what we need to do is, now that you brought it to the group's attention, it should become an issue that the group has to deal with and address. Would be the answer I would, as I'm telling you, that we have to figure out how to deal with that question. I don't have an answer for it right now, but it's something we have to deal with, and it's something we have to deal with sooner than later, because the train has already left the station.
Correct. And I would love to participate in that, and I'd be fairly vocal and diplomatic about it. Let's put it that way. But I thank you for the time. This is a great conversation.
Well, and I think it's something we have to continue having a conversation about, because, I don't have the short answer to that question. I have to think about it. I'm glad you brought it to my attention. So it would be good to put some numbers to these questions to see how much of a disadvantage we were at from a carbon point of view, and then see and then I would identify fruit and try and pick at that to get the numbers more equal, and then figure out where the real gap is, and then try and figure out what we can do about that.
Maybe I can jump in a little bit from the supply side, which could help the industry based on historical historical marketplaces that we've looked at. I think how Europe in particular has been able to start to manage this particular challenge is that they've looked at how to take the whole industry and educate the industry from a consumer standpoint all the way to the manufacturing standpoint, and look at the supply chain component, develop the standardization that everybody has to adapt to, and then look how the effect is on each particular marketplace, and then start to drive it from that point. What the challenges that we've seen in North America is that most of the producers are kind of at their own, they're left to themselves, right? They have to develop the marketplace, they have to develop their own standardization, and that's put a lot of burden on the producer, and also has let's say slowed the industry down. What's great about these kind of conversations and truly understanding it is that the key is from our standpoint anyways, is the key is to start to work together as a group collectively to agree to the standardizations in the marketplace, then drive the not only the industry itself but also the supply component to be able to help Bruno, Michael, to be able to start to drive those costs down and get the footprint closer to the marketplace. Those are just what seems to be happening in Europe, and it's giving them some great efficiencies, and those efficiencies are actually allowing them to export their product, which is negative on the carbon footprint component, but allowed them to drive their product over to other marketplaces like North America. So.
How long have the Europeans been doing this?
Well, I mean, the Europeans started, if you look at the history of a window, the European, Germany in particular, started to engineer their windows back in right after the Second World War. They looked at the components of manufacturing, and they established back at that time the tilt-turn window, which was adopted back in 1957, and then they started to drive it. But in the last 10 years, they've looked at the energy efficiencies of windows, and they, as let's say, as the government component of it, started to drive the industry to a higher performance window system, and they put incentives into the marketplace to help the producers, either small or large or medium, be able to retool to be able to get that efficiencies into the marketplace. The other thing that the government did was to also help educate the consumers to be able to why they should buy this kind of window for these various reasons. And so that's been happening now in Europe for well over 50 years, but very concentrated in the last 15 years.
Yeah, but the difference in the European market is that the homes are generational, right? Whereas in North America, the homes aren't generational homes, and typically they go through a major revamp in, on average, anywhere 7 to 12 years. So, building a window that's going to have a life cycle of 100 years is not as important, because our homes aren't built to be generational. And these are the concerns that Canadian manufacturers or North American manufacturers should have. Europe's done a great job, but I know, like, my great grandmother's house is still in use today, still within the family, and it was built like in the late 1800s. My parents' first house, we've been in 7 houses, and I'm 45 years old. And they constantly get renovated. So I think this is all part of what we need to discuss as well with the government, because it's going to put us in several disadvantages, and there's going to be cost prohibition on it. And we're going more into these are big concerns for our industry. I know they've been brought up, and maybe I'm the only one who's vocal about it enough to say live on a Tech Talk, but we're not building generational homes here in North America. We're not. And that's
Mike, I'd like to bring us back to the topic at hand. We have 10 minutes left in the show. So I'd like us to focus back onto the wood window question. I think we're going to have to return to this embodied carbon topic. Clearly, it's of interest, and you're bringing some really high level implications to it. I would like just to return the conversation back down to the level of windows right now, and specifically wood windows. And I think what's one of the relevant things that Austin mentioned is that architects, when they're looking at the embodied carbon question, they're starting to think about their windows, for example, and all the building components at the schematic design stage. It's part of the decision making about which direction they're going with on this building. And so I think that the decisions about embodied carbon are going to be made much earlier in the design stage, and architects may be deciding on something like a window frame material much earlier than they would have traditionally. Before, it would have been a U value, an energy thing. They'll sort that out later in the tendering and construction process. Now it might actually end up in the specification that they want wood windows, or they want a window that actually stores carbon and not just consumes carbon, looking at those numbers. And, from that perspective, this is something that could actually be a new market driver potentially for wood frame windows in buildings. What do you think of that, Austin?
I got most of your question. I can actually see you now, Al, so I'm happy about that. But I do think you're right. It is going to be a driver. And I think you're going to see more and more people wanting wood windows because they intuitively understand that they sequester carbon and that it would have a low carbon footprint. And also it has far less and other environmental impacts associated with the wood windows. So it does bode well for wood windows, particularly over the next 10 or 15 years, where it's incredibly important to get as low an embodied carbon number as possible, given the urgency that everyone is putting on the climate crisis.
So let's segue now to Kyle at Westech Windows. Kyle, you folks decided to introduce a very high performance wood window rather than with, you traditionally, I think Westech has made wood windows, but you guys decided not to pull out of wood windows, but you might say to double down on them. So maybe tell us about what led to that decision and how you came to design the product you did.
Oh, perfect. Thanks, Al. Good points all around. I think I could probably comment on many things, but in the interest of time, maybe I'll focus on the wood window here. I think much like any other product you're bringing in, when you start hearing rumblings in the marketplace of high energy efficiency, passive house, maybe in our market started years ago almost as a buzzword and then starts gaining traction. Westech decided years ago, 2016, 2017, to try to stay ahead of that curve. We had already produced a wood window, a full wood window, and of course a metal clad window. So we already had the ability to produce. So maybe that's why we are able to more easily go in the direction of a passive house wood window, because we had the infrastructure within Westech to do so. So initially we just started reaching out to see what the market was looking for, what we could achieve, and good partners like Randgate helped us do that. So it wasn't an easy process and a quick process by any means. There's a lot of thermal modeling upfront, design changes. One of the benefits of wood product in itself is that if you have the tooling and the machining to do so, there's no real limit in design geometry. It's more based on aesthetics at that point. So as long as you can get the structure and the thermal properties within the wood product, and of course some addition of other materials, and you get it looking okay or looking as good as possible, you can start the market, the push out to the market in that way. So we worked with Randgate over a year and a half perhaps, and ongoing to develop that with a lot of back and forth, thermal modeling, designs, material sourcing. With our wood window passive house, it's not only wood. We have some thermal cork in there. We have a thermal wrap and other products that you can see from our certificates. So it may not be as easy as just switching back to wood or moving forward with wood, but it is certainly possible to make that happen. I like the comment, Al, about and Austin's about getting the windows and doors essentially sorted out in the design stage of the buildings. Because I think too often we have, I've seen personally where the countertops have been purchased, cabinetries purchased, and then it's, oh yeah, let's deal with the windows, which has worked in the past, but it doesn't work well for what we're speaking about today, because then you're blowing budget almost on things that may or may not lead to energy efficiencies, when maybe some more thought needs to be put up front with the windows and doors and such like that. So
what made you decide to go with an outswing window design as opposed to the tilt and turn that most existing passive house windows had?
There's 2 or 3 reasons. We went in a way that we had the ability to design from scratch. So we weren't dealing with necessarily a tilt and turn hardware situation that we had to adapt around. We also wanted to keep it in our marketplace with his Pacific Northwest here and the outskirts. We see a lot of outswing casements, primarily in sliding windows. So we kind of went in that direction. So you could still have a nice, beautiful wood window. It will still operate in such a way that our local market is used to. And we could design it in such a way to have the highest efficiencies possible. So that's kind of the thought process in there. And of course, with the first outswing casement wood passive house window, or having that potential to have that under our belts, certainly allowed us to drive forward in that direction.
And Greg, I wonder, is there more that you could share about the relationship with Westech or the process of how to design a window like this?
Sure. Yeah, I'll jump in on this part here because it was a task. It was a great journey. It was probably well over a year and a half. Definitely some challenges, but we really take our hat off to Westech to wanting to take on such a challenge in the marketplace. They definitely saw something forward, definitely forward thinking. In speaking to their team there, they wanted to come up with something that was going to be effective in the marketplace a good 5 years in the future. And I agree with Kyle that, why not build a marketplace that a product that is more in line with what is an accepting product in the marketplace, which is an outswing window. The challenge that I think we had and we still are having is the acceptance in the marketplace with the hardware producers, because in the design component, we were utilizing a traditional tilt-turn window hardware. So that means it's a multi-point lock system, typically designed to go inward. A lot of reluctance on the side of the hardware companies joining forces with us to try to change the thinking about how to really drive this forward, and a lot of reluctance, a lot of challenges. I think we're getting to a point now that we've gained that acceptance. We do still need to go through a few steps to be able to make sure that it's going to not just it's functioning absolutely properly, but be able to drive the cost down to help Westech be able to gain market share, I think is the final stage that has to be done. Processing, a really good team at Westech willing to think out of the box on how to process things slightly different, because these are very large frame sections and very large components that need to be machined in a particular manner to be able to not only gain efficiencies, but also to have a good finished product. So it's been a great journey. I think they're definitely a company that's helped us develop a template to be able to move a product forward in a marketplace. We are, as a company, have since gone on further. We've helped others to develop similar things, and we're driving now to how do we develop a product range that allows the smallest producers, the ones that are closest to the ground, closest to the marketplace, be passive certified. So that working with Westech's really helped us drive ourselves even forward to a greater extent too.
So Al, just to continue our tradition of going a little bit over our time, we have a couple questions here if you want me to get to them.
Let's see. Okay, I did want to ask one or two more questions
Sure.
of Austin and Greg, maybe before that. Austin, one of the things you've pointed to is that, you know, a lot of the embodied carbon in a product comes from the actual manufacturing operations and the carbon in the power source of the plant. So for example, if you're burning carbon fuel, let's say if you're using electricity in a plant, if you're in a province with a dirty grid, you're going to have a higher carbon input into your product, whereas the same factory in a province with a clean grid would have a lower carbon footprint.
Right.
You know, and you had some thoughts about, you know, measures that a manufacturer can take to just reduce their own local contribution to the carbon impact.
Right. I mean, when we were talking about it, it was as simple as changing out the lights to LEDs. But one of the other ideas that, you know, you can think about is introducing more daylight into these buildings, you know, from an architectural point of view, much like they did back in the day. And a lot of the solutions that they used when energy wasn't cheap before the Industrial Revolution kicked in, we could reconsider. But that's something. The point of that is that every manufacturer has to look internal to them in their operation, and even recognizing light bulbs, or recognizing, you know, control systems, or recognizing schedules and loads. That all has to be part of the analysis of trying to get their window product more energy efficient, more reduce its carbon footprint, and reduce its EPD and its upfront embodied carbon. So that's a good thing, now, is what I'm trying to say. Yes. That, you know, I want to say though is that, you know, in my way of thinking, when you're dealing with these fossil fuel issues, you know, you're one step. The embodied carbon question for a manufacturer is one step removed from an operating energy question. If you just did simple energy audits in your building, you would be helping your embodied carbon value for your window. So it's a win-win situation. And the point is that that's the connection people can make, and want to hope they make that connection out of this presentation or presentations like it, that it's not just about the materials that make up the window. That's a big key component, but thinking about it holistically, there's a lot of other little side issues that come into play. So there we are. Yeah.
And then I have a question for Greg. You know, you made a comment the other day that was really interesting to me, but we look at, you know, architects today, if they want passive house wood windows, where are they buying them from?
They're buying them from Europe primarily, yes.
They're buying them from Europe. And, you know, we know that Europe is out of old growth forests. We know that Europe is kind of short on forests. So where are the European passive house window makers getting their wood?
In often cases, from our research, they're actually getting them from North America. So.
And specifically, you mentioned that there's a supplier of window scantling in BC. Tell me about that story.
Yeah, it's an interesting. To me, it's a very interesting story, because we had a small client that was up in Fort St. John's that was looking to do a high performance window, and from their own research, they found a small, let's say, small producer in Abbotsford, BC, that was making traditional tilt turn scantlings for the marketplace, Doug fir, hemlock, you know, typical materials here in the Pacific Northwest. So we visited that supplier along with our client and two clients, one from Colorado and also one from California. And in the conversation, the producer of the scantling, who is primarily selling his product container loads to Germany, Austria, and Italy, we asked them, you know, why aren't you selling this kind of product to North America? He says, well, because nobody's asking me for the product. But if you look at what is going on here, he has container loads of this finished 50, at that point, 68 millimeter and 78 millimeter materials ready to go, going to producers in Europe. And our guys are looking for a cost-effective way. And when he quoted out the pricing to these three clients, the pricing, I mean, they just They couldn't believe how competitive the pricing was. So to us, what it was there seemed to be a very much a disconnect between what was available in the marketplace, what their needs were in the marketplace, and it's really from these kind of discussions that we're having now about what truly needs to help drive a marketplace. There is opportunities there, but we do need to really open this up and look at how each component of the marketplace, what their requirements are, and just keep driving it as deep as possible. I think this conversation is great. I think Austin has really opened up an opportunity, and I think Kyle has clarified it in my mind, is that we've always thought of performance at the end. But looking at the carbon footprint at the very beginning, there is opportunities that can be developed. There's a lot of work that has to be done. It's not going to be just hit it out of the ballpark. Kyle and Westech has proven that there is work to be done, but there is opportunities. There's just this disconnect, the lack of communication between the groups of individuals, so producers, suppliers, governmental, but also the consumers, and then the architects. So I'm, as a component of this industry, really excited about what Austin is doing and helping to educate the future architects on how to be able to really drive this industry forward. I think it's going to help Kyle and others produce a product that is correct for the marketplace.
So you mentioned yesterday, in conversation that, there's Canadian wood going to Europe and potentially round tripping coming back to Canada. You also mentioned aluminum. Could you talk about that?
Yeah, I mean, from our side, because we are very heavily involved in the tilt-turn marketplace, it's the cornerstone. We often get asked of aluminum cladding, and we've done many trips where we've taken clients over to the Gutmann factory in Germany to show them aluminum extrusions made for traditional tilt-turn windows. And when you're in the parking lot there and they're unloading raw ingots of aluminum components, they have Alcan aluminum stapled all over every one of the loads that are coming off. And I asked the producer, Gutmann, where they get their aluminum from. They said, well, we get them from Alcan in Quebec, Canada. It's the best source. It's the most competitive. And the wood producers who are with me, we all just sort of look at ourselves and we're saying, we're flying all the way over here to Germany to watch how they're making aluminum extrusions because our clients in North America are asking of that. But yet my raw material that is going to go on that window is coming from Quebec. So there is definitely opportunities if we start to work together to develop the marketplace that we really do not need to go to the other side of the lake to get a drink of water. So
yeah. So I think it's ironic that we have Canadian wood and Canadian, BC grown wood. We have low carbon aluminum from Quebec, which is I think considered one of the lowest embodied carbon aluminum sources because of their hydroelectric power, going to Europe. And then when architects want to order aluminum clad wood windows, they get them from Europe, using our wood and our aluminum, round tripping around the world. So I thought that was ironic, but it's also interesting. And I'm hoping that this conversation and other conversations like this will kind of stimulate more thought within Canadian industry about the embodied carbon questions and about how we can take advantage of the resources we already have here within Canada and be our own suppliers of these products. As Kyle and Greg have demonstrated, we have the know-how to design these products. It doesn't reside just in Europe. We have the technical ability to actually manufacture them. And potentially, if we play our cards right, we would also have a really good carbon story to tell as well. So I was hoping that we could conclude the show on this note, that this may be the first conversation we've had at Fenestration Canada about embodied carbon, but hopefully there'll be opportunities for more as we think about this, not just with respect to the wood window industry, but I think it is really, I think people in the wood industry need to appreciate that this conversation may actually be relevant to that sector of our fenestration manufacturers. and hopefully stimulate some thinking and innovation to benefit all of us.
Great.
Any important questions, Stefan, that we should look at? Or
Yeah, well, we have two questions left here that we could have a look. We literally have, let's say, 2 minutes to answer both. We have two, but maybe we try. So George is asking, Austin, could you please share your sources and links of anything open source LCA tools you mentioned? So is that something possible for you to do?
Yes.
Okay.
I'll send that to Al, and then Al can send it out.
Perfect.
Sure.
We'll, we'll probably put that in the video here. And Doug Thompson's asking a question for Kyle. Can you share with us the thermal performance increase results in the wood passive house window compared to your existing wood window offering?
It's an interesting question, because with our passive house wood window, we have our results as they are to get certification, but it was also designed in such a way that through the glazing packages need not be a wood passive house window. So we had our old existing wood window, which has been replaced by our new design, which we have passive house certification for. But also, if you move back to a double glazed window, or maybe a triple glazed IGU with maybe one low E coating, we wouldn't get that certification from passive house necessarily, but it's almost like a like for like comparison. So if we were to do a wood window with a double glazed unit, just a low E coating on the number 2 surface, you know, we're looking at maybe a 0.159, whereas our passive house offering, depending on the glazing packages, you get 0.8 and lower, and whatever the building would request for that. So it's quite interesting that within the one frame that we designed, a picture window and an operable sash, and that with one design, we have 2 different product offerings. A typical wood window for maybe a building code minimum home, or anywhere from that minimum up into the passive house certification and then beyond, all with one design. Okay. So you're looking at, depending on the glazing packaging, saving or increased performance 40%, 50%.
Sure.
Would all vary, but it's one of the good aspects of having the ability to design that window frame in such a way to manufacture it for us across the board as a building code minimum and a passive house and beyond.
Well, thank you very much, Kyle. Thank you for our listeners and your questions. And thank you to our guests, Austin Parsons, Kyle Cartwright, and Greg Godbout. Appreciate all of you taking time to be with us today on Tech Talks and to kind of expand our understanding of this, topic that is emerging and I think will become even more significant over time. So thank you to everyone online, and thank you to our guests, and we'll see you on Tech Talks next time.
Thank you.
Thanks, Al.
Thank you very much.
You are a member and want to be part of the live recording of Tech Talks? Easy. Visit fenestrationcanada.ca and sign up for the next show.